Hello everyone. So welcome to the question 43 of GATE 2019. So this is a question from compiler design which carries 2 marks. So you can see that the question is taken from the parsing part of compiler design. So here consider the augmented grammar given below. So they have provided the grammar and they are also telling that I0 is the closure of S bar goes to dot of S. Okay, and they are looking for the number of items in the go to set of I0 in this one. Okay, less than sign. Okay, so firstly let's discuss about what is closure property. I mean, what does it mean by closure and what does it mean by go to? Okay, so this is our grammar. Okay, we'll discuss the main concept of closure and go to in the path itself. Okay, so firstly this dot, okay, dot itself, see they are telling that I0 is the closure of is if bar goes to dot of S. Okay, it means that we are starting the parsing of the string. Okay, uh, I mean, our whole string will be derived by this S, right? So our main target will be that we'll parse the S. Okay, this is our main target. So this dot is representing that till now we have parsed how many things and what are the things left. Okay, if we have parsed something, then that will come to the left side, and if we are going to parse something from now, then that will come to the right side of the dot. Okay, so it is just telling us that how much we have parsed till now. Okay, and now the rule is that for closure, if we have dot before some non-terminal, okay, if we have dot before some non-terminal, here this s bar goes to dot of s, and s is the non-terminal, right? So if we have dot before some non-terminal, then all the production rules that are starting from that specific non-terminal will come. Okay, so here we can see we have two production rules, that is s goes to less than l greater than, then s goes to id. Okay, we have two more production rules, so those two will also come and we have not parsed them, right? So this is the very basic or initial situation. Okay, now from that stage we can have three parts. Okay, from this stage, from I0 we can have three ways. Okay, what are the three ways? Firstly, either we can parse s. Okay, if we are parsing s, then what will happen, our dot will go to the end. Okay, and then we may parse to the less than sign. Okay, if we are parsing to the less than sign, then firstly what will happen, our dot will, I mean, parse L. Okay, I mean, our dot will like cover, I mean, we'll parse the less than sign and our dot will be before L. Okay, as it is coming before some non-terminal, it is coming before some non-terminal, right? So whatever the production rules that are there, using that non-terminal, we have to write that. Okay, so here we can see L goes to L comma S and S. So these two production rules we have. So L goes to L comma S, right? So dot will be before that and L goes to S. Okay. Again, now we can see we have some non-terminal. We have some non-terminal before which we have the dot, right? So then we again need to write them, but we have not passed, right? So this is the stage of I2. So we can say that this is the closure of this thing, right? L s goes to this less than dot L, okay, and greater than this production rule. And we can say that I0, if it is being passed by less than sign, then it is going to I2. So it is go to, I mean, I0 less than, if we take the go to of that, then we'll get I2. Okay, now again let's complete the whole tree and let's discuss it further. Okay, so from I0 we can see that we had three paths, right? For first path is we can get S, right, by which we will get I1. Then second path is we can get less than sign. Okay, I mean we'll parse less than sign, then we can go to I2. Then the last is we can get ID. Okay, we may parse ID, then we will get I3, and we can say dot is after ID, that means we have parsed ID. Okay, now here for I1 and I3, we are already done because dot is at the end. It means we have passed everything. Okay, we want to look into it further. So what is left? We are left with I2 only. Okay, so let's parse I2. So first thing is that we have this L goes to S. Okay, we have this third production rule. L goes to S, right? So we can simply parse it. There is nothing after the dot, so it is a simple one. Okay, we have parsed it. Okay, so we got I4. Okay, next we can parse L. Okay, so if we are trying to parse L, you can see that if we are trying to parse L, we will have two production rules that will be parsed. That is first one that is S goes to less than dot L, and the second one, right, L goes to dot L, because our dot is before L in these two production rules, right? So if we are trying to parse S for both of these, for both of the cases, both of the production rules will parse L, right? So, and in both of the production rules, we can see after dot there is no more non-terminal, right? So we can just stop here, right? Till now. Next, we are having this less than, as well as we are having ID. So we can see if we are getting less than, then again our I2, our whole I2 will get. Okay, if we are getting, if we want to pass the same sign, same production rule with respect to less than, then we'll get the same I2, right? So it is kind of a self loop, but I have not shown self loop. I'm just writing it I2 again. Okay, just refer that I2 means this set itself. Okay, and in the same case, if we get ID, then we will get I3. Okay, if we want to parse by ID, we will get I3 itself. Okay, but this can be a direct connection, but I have for the sake of simplicity, I have written it otherwise. Okay, now we don't have anything in I4, we don't have anything in I2, we don't have anything in I3. Okay, now what is left? I5. Okay, so first thing is simple, that is we have this greater than sign. Okay, we have this greater than sign. So if we want to pass this, then our dot will come after everything, right? So it means our whole production rule is passed, and we won't go further for this production rule. Fine, this is okay. And now what is next? Our dot is before some comma. Okay, so what will come if we are parsing for this comma, then the first production rule, you can see L goes to L comma dot. Okay, it means our comma is passed. Okay, so if our comma is passed, then our dot is before this non-terminal S, right? and and as I told already, that all the production rules that are starting from that non-terminal, we need to write them. Okay, for all the production rules that are starting from, from S, we need to write that. Okay, so this is the closer set, right? So from that, the first thing is that we can, dot our dot can parse S itself. Okay, if we want to try, if we want to parse S, then our dot will come here. Okay, and this is our final, you know closer set. Okay, and for the other things, if we want to parse using the less than sign, okay, then our dot will go after that, and we'll get again the same thing as I2. Okay, we'll get again same thing as I2, but for the simplicity, I have written I2. Okay, there will be a direct line from I7 to I2. There will be direct path. Okay, same goes for if we want to pass by ID itself, then it will go to I3. Okay, I3 here. Here is the I3, so there will be the direct path, but we can just write like this. Okay, so from that, here we are already at the end, because we won't go further for I8, and I2 and I3 are already taken care of. Okay, so this is the overall parsing method for this grammar. Okay, now they have asked that what we how many production rules will be there. Okay, or you can say how many number of items will be there in the goto of I0 with respect to less than sign. Okay, so I0 with respect to less than sign, we are going to I2 itself, and how many items are there? We can see there are 1 2 3 4 5 items. Okay, so it means our final answer will be 5, that there are 5 items in the specific I2 that they are looking for. Okay, so I hope that this concept is clear at this stage. Okay.